Okay, so I made a mistake earlier. I put it in the comment, I think, in the subject. I went and wired my coil wrong, and I thought, oh, I see what I've done. I'd basically, well, I've fixed it now. I've put this thick wire on because, yeah, that way I won't keep making mistakes. So these two coils are in series, right? And the wire would come off. One of the down there, the thin wire, you can see it's next to the purple or black thing. That wire, I was connected to that wire and the other wire on the other end, which meant I was only connected to one coil, so I was actually only reading half the voltage. So the voltage is actually higher than what I thought, because we're actually at 1.99 volts. I have actually upped the voltage a bit on the output from the power supply, the input, sorry, because we're running we're now running at, let's see, where are we? I can't keep my hand still, hang on a minute, that's better, 5, 6, 7, 8.5. We're running at 8.5 volts, 8.7 volts actually, because the current's dropping, it's going up a bit, it's probably set to 9 volts. So the current at the moment is still dropping, but we're at 210, 20, 30, 230 milliamps, so it's dropping. So I upped the voltage a little bit because we're drawing less current. I thought, well, I can go a bit higher in voltage now because I'm drawing less current. And then when I measure the voltage, we're actually nearly 1.97 volts. Basically, we're going to be above 2 volts by the time this thing stops climbing. And so it's actually better. It's twice as what I thought. So I wanted to do an update because I hate giving out wrong information. So with that current, that voltage, the current is well, when it settled earlier, it was around 28 milliamps. It's still climbing though, so 27.1. But remember, the DC resistance of the coil as it's under load warms up slightly, so we see a few points drop. But that's normal to be expected with 36 SWG wire, because the impedance of that wire is quite high, and this is the actual wire. Sorry about my writing, it's coming off. So this is the wire I was using. Bloody thin stuff. You know, honestly, when I wire into more coils, I'm gonna go with probably gonna go with 34 SWG, because I'll get a bit more current then, and because I'm now actually getting basically a volt per coil. If you work that out, if I get a volt per coil, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we should actually get 9 volts. Conservative, you know, I mean a little bit conservative, because if this unit is inside a vacuum chamber, which I'm probably going to do it like in 6 months or so, when I can get the money, because I haven't got the money right now. I can't afford 80 quid. I just can't afford 80 quid. It's a lot of money to buy Perspex. I've been shopping around on eBay looking to try and find a cheaper source, but yeah, I have to get the thick stuff though, because it's got to be in a vacuum. It's quite a large area. The larger the surface area, the thicker it's got to be. So if we put it in a vacuum chamber to stop air resistance, because a lot of air is coming off this thing, I'll show you what I mean. We should reduce the amount of drag on it. Now I'll get my lighter. You can see how much wind is basically being thrown off this thing. So I mean, that slows it down quite a lot, really. I mean, not a great deal, but I mean, it's adding to current. And it's the larger the circumference. It's obvious. Larger the circumference, right, of a rotor, the bigger the rotor is, the more leverage the air has on slowing down a system. So a smaller rotor can spin faster simply because it's got less leverage from air resistance. So that's the reason why smaller things can run a lot faster than larger things. And it's also the other limiting factors are centrifugal force, because if the larger something is, the slower it's got to go because of stresses on the rotor assembly which will basically make it fly apart. So you're limited by RPM on a larger disc, a larger surface area. But what I'm not really trying to go too fast. All I'm trying to do is reduce my input drive current, so I can basically turn my current down, use less current to get the same revolution, which is a saving. So anything that you can save on input means that you can gain on output relative to the input, whatever. So yeah, so that's what I'm talking about. Yeah, so we're doing pretty well. I mean, 27 milliamps for those two coils. Now, obviously, I was using slightly thicker wire. I'd be getting a lot more juice, because I think previously I was over 50 milliamps, I think, with a 30 SWG wire. So with 30 SWG wire, I could get a lot more current, but then I don't get enough voltage because of the limitation on how much wire I can wrap around this thing. The only way to overcome that is to add more magnetism. Now, the other thing I was thinking about doing to add more magnetism is to get some thinner magnets around the back of here, because as these come towards the centre, they actually get closer together. So this magnet would get closer to that axis. So what I can do is sketch up a model where instead of the 8mm wide magnets I've got here, I can put behind it some 5mm wide magnets, or even 3mm wide magnets, long ones that come in to cause that flux to expand even further out. So it will expand the flux coming out into the rotor, so we get a much stronger field on the rotor assembly, the ferrite assembly that's spinning. So that's an option by putting more magnets around the back of it. So yeah, I thought about doing that as well. But it's all about finding the actually I've got some magnets somewhere, but I think they're all buried in some of my other projects. I think it's digging them all out. I've got this tray which I made for that thing. There's a load of magnets in there, the thin ones. They're like these little ones, but they're a bit longer than these. So I could use a whole bunch of these magnets, right? But the ones I've got, they're a lot longer than that. Those are short ones, but the same width. So I could use a whole bunch of that. But the trouble is, those I think they're N42s. I think I really want N52s to make it worthwhile. So anyway, as you can see, we're let's see what we're at now on voltage. Oh, we're almost over voltage actually. 1.9. It's climbing. What? So the coil's going to cool a little bit, because obviously when I put a load on it, it raises the coil temperature a few fractions of a degree, which affects the readings. So it's stabilising again, because when it's not under load, it rises a bit. But RPM is not going up at all. It's just, well, I mean, current input is not going up at all or going down at the moment. It's just steadily increasing speed because it's still charging the supercapacitors right now. I think it's reached its peak right now. It should go a bit higher than that. At least earlier on when I was measuring it, I was over 2 volts, so I'm not quite sure why it's not there yet. We're still on volts and it's going down, look. So, mind you, there'll be people, as I said before, my power supply is stabilised. It's not 100% regulated, so it fluctuates with the mains, the input voltage that's going in from the electrical supply, the grid. So as that fluctuates, it affects the output voltage a little bit, so it tends to make things go up and down a bit. So that's another factor that's annoying me, but that's why I got the supercapacitors on there, to try and even that out a bit, to make it less twitchy. Oh yeah, look, we're going to get above 2 volts in a minute. We're going to go above oh, I'm on the 2 volt range as well, so it's going to go over limit. Yeah, yeah, we're over limit now. Oh, I've gone to the 20 volt range. I think it was about 2.2, 2.02 or 2.4 or something earlier. Right, so at 2 volts now, 1.99. It's fluctuating a bit. So I just wanted to update you on that. I was charging my phone up and I thought, bugger it, I'm going to make an update video. So input current is 210, 20, 30 at the moment. It should drop even more as these supercapacitors down here charge up. Yeah, it'll probably drop a bit more. It's still dropping now. I can see input current slowly dropping. You can actually see it moving right now. You can actually see it slowly dropping. So, and we're at 2 volts still. Let's go to current. This is just going to be a short video. I don't want to be on too long. I just wanted to update you on that mistake I made earlier. Current is 27.5. Yeah. So yeah, just a little update. Anyway, at least I got this sorted out. I'm going to have to put thicker wires on my terminals. That's the whole point of having terminals anyway, is to put thicker wires on. A lot easier to see what I'm doing then. I don't have to fart about trying to find thin wires all the time. Trying to clip onto the thin wires. I should have put these on before. I wasn't thinking, you know. You kind of don't focus sometimes. These little wires, I haven't measured these since I upgraded all this, so I don't know what voltage is coming out of these little things, but yeah, I'm going to have to find out later on. But ideally they want more turns on there. There's probably something ridiculous on these little windings. Probably, I'll be lucky if there's a volt across both of these. Probably something like 500 millivolts or something. But anyway, I'm not worried about that for now. I just have to get some more wire first, and that's going to be about 14 quid probably next week. That's a week from Monday, so that's when I can probably get some more wire. Yeah, it's going to be months before I get this flipping perspex, so I don't know. Yeah, I really want to build that thing. I've got the other stuff. I've got some tube. I've got a bit of tubing kicking about, and I've got some valves which I use for my reverse osmosis that I could use, and I've got a vacuum pump, so I can basically pull a vacuum on it, but it's got to be sealed. So I'm going to make this thing. I'm going to have to glue it all together with something, and then silicone seal it or something. Use something, a good sealant, to make sure it's airtight, and use some bracing on the some of the areas so that it doesn't basically. I can 3D print stuff like that anyway. Yeah, anyway, I'm going to go because I want to get my phone charged up, and it's still pretty flat. It's only charged up a bit. It's at 53%. I didn't get much power into it. At least I fixed that little mistake I made earlier. Anyway, bye for now.